All right, I hope you guys did those problems using the video. Now here's how to do the next couple of problems in your homework assignment, problems 9 and 11. Find the displacement and total distance traveled. They give you a velocity machine. Remember, the area under the velocity curve is the displacement. And displacement is the net distance traveled. Can net distance be negative? Yep. Net distance can be negative if we're going more left than we do right, or going more down than we do up. In rectilinear motion, we go, our motion is on a line. So first, let's do the easy one, the displacement, or the net distance traveled. The net distance traveled is just the antiderivative of the velocity machine with respect to time. As we go from one endpoint to the next, I'll call this one S sub 0 to S sub 1. I'm sorry, T sub 0 to T sub 1, the times. Okay, let's put in our particular problem here. It's the antiderivative as we go from 0 to 5 of the AP writers are determining what type of questions to ask. They will make that final determination on Friday. As soon as they say how the adjusted AP test is going to, what it's going to look like, I will shoot you guys an email and we'll start focusing our attention on those problems. The rumor is that it's all going to be free response. You'll be able to take it at home, but it's all going to be free response. So you're going to have to show your work on stuff like this. And I know we can just plug this into our calculator and figure out the number, snap, and we're done. But if the AP test is free response, we're going to have to show our work. So let's practice by showing our work and then checking our answers with our calculator. Raise the power, divide by the power. Raise the power, divide by the power. And who cares about your constant, because we've got a definite integral here. So we throw in 5. I'm going to run out of room. Minus what you get when you throw in 0. When you distribute that, boom, 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 the C's cancel. So you've got 125 over 3 minus 20. The sum of the digits is 8, so it's not divisible by 3. So we're going to have to get a common denominator. Multiply this one top and bottom by 3. So now we got 60. And so this is 65 over 3. Meters, feet, whatever. This thing travels more right than it does left. Now the total distance traveled is a little bit trickier. Remember, the book sometimes doesn't use the word total. When they don't say displacement, they imply that it's the total distance traveled when they say the distance traveled. It's the antiderivative of the absolute value of the velocity machine with respect to time as we go from one t value to the next. So what we have to do on this is, you can't take the antiderivative of an absolute value function. So we're going to have to break this velocity machine up into piecewise forms, find out where it does dip below the t-axis and where it's up above, negate the known negative area, keep known positive area positive. So draw a quick sketch of this velocity machine. It's a parabola. It's open concave up, regular fatness, with a y-intercept or a vertex of 0, -4. It's critical that we find that point right there. We have to find where it's going from negative area over here to positive area. and we keep the positive area positive, and we negate this negative area. So to find this root, to find that intersection point, to find that solution, we just set the equation equal to 0. We get plus and minus 2. That negative 2 has nothing to do with the interval in question from 0 to 5, but this positive 2 certainly does. Okay, so knowing that the area is underneath the t-axis from the stretch from 0 to 2, we have to break it up and go from 0 to 2 of this velocity machine. That area is down below. We need to negate that negative area. Plus, from 2 to the rest of the distance over here to 5, again, everything's based on the interval in question. From 2 all the way to 5, we keep known positive area positive. That's the setup for total distance traveled. You guys can throw that in your calculators and figure out what the total distance traveled will be. Will the total distance traveled ever be less than the displacement? Will the total distance traveled ever be negative? Couple of good systems of checks and balances there. Enjoy.